All right, so welcome. This is going to be our first video for chemistry class, and we're going to look at kind of this week and the beginning of the next week, properties, changes, and states of matter. So really just an introduction to matter, because like we're going to talk about matter is basically at the center of chemistry. Um, in addition. One of the things that we're going to stress is a really good conceptual understanding about matter, okay? Because it being behind everything that we're going to talk about in chemistry is going to be the most important. So our objectives today, we're going to define what chemistry is and define what matter is. We're going to classify pure substances as elements or compounds and describe the characteristics of elements and compounds. And we're going to distinguish between pure substances and mixtures and classify mixtures as heterogeneous and homogeneous, right? This might seem like a lot, but once we get into it, it's going to seem pretty intuitive. It's going to seem like it kind of makes some common sense. And when we have some work time here on Tuesday, or no, on Wednesday, because today's Tuesday, on Wednesday, um, we will be able to answer questions as far as this goes. So, um, the formal definition of chemistry is it's the study of matter, the substances that matter makes up, and the properties and interactions those substances have with themselves and with other substances around them. And we can divide chemistry as a subject into kind of five major areas. There is organic chemistry that has to do with the study of all substances that contain carbon. Inorganic chemistry, that's what mostly we're going to talk about, the study of substances that don't really have carbon as one of its main pieces. Analytic chemistry, which is the study of like what makes different substances up, and especially the percentages and the proportions of those substances. Physical chemistry, which kind of combines physics and chemistry to study the theories and the experimental behaviors of different chemicals, and then biochemistry, which is the study of the chemistry of living organisms. And so, if my plug for if you're uh, any any interest in going into health or pre-health fields or anything to do with living systems, biochemistry is going to be very important for you. So first and foremost, like I had just mentioned, matter is the most important thing in chemistry because we're studying matter. So matter is anything that has mass or takes up space. So for example, everything that you can see and that you can touch, and then a lot of things that you can't see and you can't feel are made up of matter. Things like ideas or things like shadows aren't matter because they don't have mass and they don't take up space. Now we can divide all of matter into two bigger groups called pure substances and mixtures, right? And pure substances is the first branch of matter. Pure substances are samples of matter that always have the same composition. They're always made up of the same pieces every single time in the same ratio, right? Um, every sample of a given pure substance has the same property. So for example, gold is a pure substance. It is only made up of gold atoms. Okay? That's all that is made up of. Magnesium is also a pure substance. It's made up of one magnesium atom and two oxygen atoms in that specific ratio, one magnesium to two oxygens. If there are two magnesiums, it would be a different substance. So pure substances are always the same composition, always made up of the same stuff, components, and those components always exist in the same ratio, this many to that many. Think of it like a recipe. right? Your recipe for your cake might have 2 eggs, a cup of sugar, a cup of flour, okay? That stays the same for that recipe. It never changes. If it changes, it's a different recipe. If it changes, it's a different substance. There are two smaller categories of pure substances called elements and called compounds, and we're going to look at those kind of next. Elements are substances that can't be broken down any simpler because they're made of completely only one kind of atom. So elements are substances that are all only made up of one kind of atom. Carbon atom, hydrogen atoms, oxygen atoms, okay? There are 119 elements that are all found on the periodic table. So if something is an element, then it's on the periodic table. There are no elements that we have discovered yet that aren't on the periodic table. 88 are found naturally, so about 90%, and others are made synthetically or in labs. Some elements are very rare, and really only 12 elements make up most of the things that you see in your daily life. With the exception, and this is kind of my blow your mind kind of moment, with the exception of hydrogen and a few others like helium and stuff, all elements are remnants of supernovae, stars that have exploded long before our solar system even existed, many, 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 many light years away. So here are some examples of elements. Here are different circles representing, see how each of the atoms are different types of atoms, and the periodic table that we can see every single element. So today when you're classifying things, deciding whether it's an element or not, look at the periodic table. Is it found on the periodic table? Then it's an element, right? And the other type of pure substance is a compound. So a compound is a substance made of atoms of more than one element bonded together, chemically combined in a specific proportion. 1 oxygen to 2 hydrogens. That's water. Okay, for an example. Um, Unique and different from the elements it contains. So compounds have different properties from the elements that they contain. So for example, water is a compound. 2 different types of atoms, hydrogen and oxygen, combined together in a specific proportion, 2 hydrogens to 1 oxygen. If there were 2 hydrogens and 2 oxygens, a different proportion, we'd have a different compound. That would be hydrogen peroxide. So hydrogen is a gas and it's colorless, and so is oxygen. Hydrogen and oxygen are both non-toxic. Hydrogen is volatile, so is oxygen. But when we put them together, water has completely different properties than either hydrogen or oxygen. So here are some examples of compounds, all right? Combining two or more elements chemically. So look, they're bound together, not just floating around with one another. And I mentioned they have the same chemical formula. These are their chemical formulas below. All right. We're going to learn how to write those later in the class. But a compound will always have the same chemical formula. So water will always be H2O. Carbon dioxide will always be CO2. It will never change. Right. Mixtures are the other type of matter. There are pure substances, which were made up of elements and compounds, and mixtures are the other big branch. Mixtures are a combination of more than one compound or element that in a way that's just mixed together. They're not chemically combined at all. So if we could take 2 or more elements and just mix them up, or 2 or more compounds and mix them up, or some elements and some compounds and mix them up, we'd make mixtures. So salsa or air or salad or pepper, these are all mixtures. And kind of like pure substances, there are two smaller categories of mixtures. There are heterogeneous and homogeneous mixtures. Heterogeneous and homogeneous mixtures. So heterogeneous mixtures are ones that are not uniform in composition. They look different throughout. Hetero means different. Heterogeneous mixtures look different throughout. So different components we can see individually with our naked eye. So for example, in lemonade, you can see like the liquid part, the water, you can see the pulp floating around in it, or in this mixture of marbles, you can see the individual different marbles floating around. That makes it a heterogeneous mixture. On the other hand, homogeneous mixtures are substances that are so evenly distributed, so evenly mixed together, that it's really hard to tell the difference between where one substance and the other substance that makes up the mixture is. So it appears to all be one substance. It's easily confused for maybe a compound or an element, but they're actually mixtures. So for example, stainless steel is a mixture of iron with some carbon. Okay, it's an alloy. It has different metals combined, but you can't pick out oh, there's a piece of iron, there's a piece of chromium, there's a piece of nickel. Or sugar water. It has water and sugar dissolved in it, but you can't look unless it's super saturated and see the individual pieces of sugar. So, some pictures to help reinforce what we've been talking about. This is an element, hydrogen, one type of atom. This is a compound, water, two different types of atoms chemically combined. Look how they're attached, they're chemically combined together in a specific ratio, two hydrogens to one oxygen. These are mixtures, okay? Mixture of hydrogen and oxygen. Look at how, unlike water, the hydrogen and the oxygen aren't chemically combined. They're just mixed together. They're just mixed together. So, kind of reviewing what we talked about, you could create a flow chart to help you identify the types of matter. First, can you think of it? Can it be physically separated? If yes, it's a mixture. If no, it's a pure substance. If it's a mixture, is the composition uniform? Can you see different parts of it? If yes, it is uniform, it's a homogeneous mixture. If no, it's not uniform, it's a heterogeneous mixture. And for a pure substance, can you chemically decompose it? Can you break it into smaller pieces? If yes, it's a compound, and if no, it's an element. All right, and so lastly, I think the hardest part is to tell the difference between a mixture and a compound. So here are a little graphic organizer to help you differentiate those things. Okay, with all of the different ways that we might think about telling the difference. All right, that's kind of what I wanted to make sure to go over for today. Um, and we're going to talk about this during Zoom session on Wednesday.